Introduction. Why social science? Theme A. India and the world, land and the people. Sub-theme: landforms and life, oceans and continents, locating places on the earth. Theme B. Tapestry of the past. Sub-theme: timeline and sources of history. India, that is Bharat, the beginning of Indian civilization. Theme C. Our cultural heritage and knowledge tradition. Sub-theme: India's cultural roots, unity in diversity, or many in one. Theme D. Governance and democracy. Sub-theme: family and community, governance, local government in rural areas, local government in urban areas. Theme E. The value of work. Theme E. Economic life around us. Sub-theme: the value of work, economic activities around us. Then there is a picture in that two mountains, a lake, forest, a small house, and a road has been shown. Let's explore. Observe the picture above. What do you notice? Where does the water in the lake come from? Answer could be: the water in the lake comes from the rain. Who made the road and why? The road is made by urban government. For village, it can be rural government, and for cities, it can be urban government. What could be activities of people living in the small house? The activities that can be carried out by people living in small house are: they can perform agriculture, they can do fishing, they can work in NCERT. What could be their history? They could be the tribal peoples of that area who were residing there since the beginning. Their future depends on their decision. Next question. Write down your answers and discuss them with your classmate. Now, looking at the picture on the facing page, what questions come to your mind? Write them down. Next. How do you propose to find answers to the questions related to these two images? How are our questions above relevant to social science? We live in the 21st century. If you do not know what this figure really means, you will soon learn about it. Everyone agrees that it is particularly challenging time for humanity. There is a picture. On the one hand, there is rapid progress in technology, which is changing our lives in many ways. On the other hand, the world is witnessing multiple wars, armed conflicts, and rising social tensions, and our planet's natural environment is under great stress. We live in an age of great possibilities but also great challenges. The world over, more and more people wonder, how do we solve the problem facing humanity? How our societies learn to live in peace and harmony? How can we protect this beautiful earth which we all share, and protect it not only for ourselves but also for all the species that live on it? These fundamental questions are simple But the answers are not. They cannot be simple because human societies are very diverse and complex. If we wish to find answers to such questions and help build a better future, we first need to understand our world and human societies in particular. This is what social science is all about. You may wonder whether this is a science like, say, physics or chemistry. It is not. The discipline does use scientific methods wherever possible. You will see a few examples in the textbook, but it focuses human society is again too diverse to allow the kind of set procedures and fixed results the science come up with. Social science has many sub-disciplines. For say, geography, history, political science, economics, sociology, anthropology, archaeology, psychology, and a few more. You need not feel intimidated by all these terms. While you will study some of these sub-disciplines in the secondary stage, in the middle stage we have avoided this classification. Instead, we have opted for 5 broad themes. Let us briefly look at them. Theme A: India and the world, land and the people. The first theme includes the basis of the geographical world around us, some of the main features of our planet and the way to represent them on a map. Why is this theme important? When today we can get excellent maps on mobile phones, because it deals with much more than maps. It also asks how geographical features, oceans, mountains, rivers, etc. have shaped entire civilizations throughout their histories. It is also, in India's case, about how its natural setting has contributed to giving these ancient civilizations a unique identity. Theme B: Tapestry of the Past. A tapestry is a large piece of canvas-like cloth usually kept as a wall hanging, with pictures and designs on it. Sometimes a historical narrative. Our tapestry is where we will be painting scenes from the past, beginning with India's past. But why should we be at all concerned with the past? Because it is the key to understanding the present, and the chapters in this theme will often make this connection clear. The past is a major source for our identities. It helps us understand who we are and where we come from. The past is still with us. In other words, and since history is unfortunately not all about happy developments, it is useful to understand where people, governments or rurals went wrong and why. Only then we can hope to avoid repeating those errors. Theme C: Our cultural heritage and knowledge traditions. It has often been said that India has a rich and ancient culture. True, but what are its main characteristics? Its guiding principles? How has it manifested itself in India's history? How can it help us to deal with issues of our times? These are some of the questions that this team is exploring with the objective that every student should understand some of the cultural foundation of our civilization and learn to appreciate their values. Theme B: Governance and Democracy. Citizens of any country should know how their political system functions. India, as the world's largest democracy, has an elaborate system working at different levels. What are its chief characteristics and components? How do the citizens participate in the overall governance? What are their rights and also their duties or dharma? Are there different systems in other countries? And if so, of what type? How are different countries supposed to interact? By studying this theme, we can become more responsible citizens, understand how the organs of the government functions, and learn to have a say in the policies that affect us all, whether locally or nationally. Theme E: Economic life around us. No family can be happy without the essentials of daily living, at least food, clothing, shelter, access to water in a first stage, in a second, livelihood for adults, and access to education for the younger ones. Similarly, no country can develop harmoniously without a second economy. But how does an economy work, especially in a huge country like India? What exactly is money? Where does it come from? How can it be increased? What economic activities can people engage themselves in? How are natural and human resources best managed? This theme will lay down some of the important concepts and practices that will enable us to answer these questions. You will notice that there are many questions in the preceding paragraphs. This is as it should be. Social science is also about the art of asking the right questions. Only then can we start looking for the right answers. This also explains the presence of big questions at the start of each chapter in this book. You may also be intrigued to find a game of chess and some ancient Tamil poetry in chapters that apparently deal with geography. A discussion on the use of the sari in a chapter or cultural heritage, the concept of seva, and the mention of festival in chapters focusing on economics. This is deliberate. We believe in bringing elements from diverse fields together. You will learn later that this is called multidisciplinarity. This enriches our perspective. Indeed, life constantly mixes numerous elements together, so why should we not? By now, it should be clear that although social science makes constant use of the past, it seeks to make sense of the present so as to help us prepare a better future. It is an exploration and an adventure. Chapter 1: Locating Places on the Earth. The globe of the Earth stands in space, made up of water, earth, fire and air, and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic, by Aryabhatta about 500 Common Era. Then there is picture. The big questions. What is a map and how do we use it? What are its main components? Question 2. What are coordinates? How can latitude and longitude be used to make any location on the earth? Question 3. How are local time and standard time related to longitude? Imagine that you are visiting a city for the first time. How would you find the places you want to visit? You might ask a local person for help, or you might look at a map of the city. In previous grades, you learned a little about maps, and in this chapter, we will study them in more detail. Let us play a game. Examine the map of this small city, figure 1.1. Imagine that you just got off a train at a railway station and you want to visit the bank marked on the map. Which way would you go? Are there other possible ways? Can you locate the public garden, the school and the museum? If you want to proceed from the bank to the market, which way will you go? This is where a map comes in handy. There is a picture. In this picture, first we can see the direction that at the top it's now north and opposite south. Then on the left is east and right is west. There are apartments. There is a railway station. There is another panchayat, a garden, a bank, a hospital, a school, market, water bodies, museum, and road connecting each other. This is figure 1.1, a map of an imaginary small city. A map is like a treasure guide. It shows you where things are and how to get to them. Notice the 4 arrows in the top right corner of the map. We will soon see how they point to some specific directions and make maps even more helpful. Let's explore. On the map in figure 1.1 given on page 8, mark the hospital. Second, what is the meaning of blue-colored areas? Which is farther away from the railway station, the school, the Nagar Panchayat, or the public garden. As a class activity, form group of 3 or 4 students each. Let each group try to draw a map of your school and some of the streets or roads that lead to it, and a few neighboring buildings. At the end, compare all the maps and discuss. A map and its components. From this simple example, we understand that a map is a representation or a drawing of some area. It may be a small area, a village, a town, etc. A bigger area, say, your district or state, or a very large area like India or even the whole world. In a map, You look at the surface as if you are viewing it from the top. An atlas is a book or collection of maps. As you will discover, there are several kinds of maps. Physical map, which mainly show some natural features such as mountains, oceans and rivers. See an example in figure 5.2 in the textbook. Political maps show details of countries or states, boundaries, cities, etc. For instance, a map of India with all its states, union territories, and their capitals. Thematic map with a specific kind of information. Example includes figure 6.3 and figure 8.1 in this textbook. In addition, there are three important components of map: distance, direction, and symbols. You have already experienced the first two while navigating the map in figure 1.1. Let us now define them more precisely. Have you ever wondered how a huge place can fit on a small piece of paper? It is all thanks to the map's scale. Let us go back to our map of a small city, that is figure 1.1. Each centimeter on the map, as printed here, represent a certain distance on the ground. Let us suppose it is 500 meters. We say that the scale is 1 centimeter is equal to 500 meters. Now, turn to the map of India in figure 5.2 in chapter 5 of this textbook. The scale is represented in the bottom left corner by a ruler with 500 written above its length and kilometer on the side. It simply means that this ruler, which measures 2.5 centimeters in the printed map, corresponds to 500 kilometers on the ground. So, the actual distance between 2 points represented on the map depends on the scale that the map is using. Let's explore. Draw a simple map of a school playground. Let us assume it is a rectangle 40 meters in length and 30 meters in width. Draw it precisely with your ruler on a scale of 1 centimeter is equal to 10 meters. Now, measure the diagonals of the rectangle. How many centimeters do you get? Using the scale, calculate the real length of the playground's diagonal in meters. Let us return to the 4 arrows at the top right of the small city map. They point to 4 directions, which are north at the top and moving clockwise, east, south, and west. These are called the cardinal directions, also cardinal points. Other than these, intermediate directions are also used. Northeast represented by NE, southeast represented by SE, southwest represented with SW, and northwest represented with NW. Most maps simply have an arrow marked with the letter N, which points to the north direction. There is a picture attached here. Let's explore. Consider the map of the small city again. Identify the correct and incorrect statements in the list below. First, the market is north of the hospital. Second, the museum is southeast of the bank. Third, the railway station is northwest of the hospital. Fourth, the lake is northwest of the apartment block. Taking your school as the starting point, do you know approximately in which cardinal direction your home is located? Discuss with your teacher and your parents. Symbols are another important component of maps. Our map has small drawings of actual building and a few other elements, but there would not be enough space on the map of a large city or a country to draw them all. Instead, a symbol is used to represent these features. Symbols for different kinds of buildings, for instance, a railway station, a school, a post office. For roads and railway lines, and for natural elements such as a river, a pond, or a forest. In that way, numerous details can be shown in the limited space available on a map. To make maps more easily understood by a variety of users, map makers use specific symbols. Different countries use different set of symbols. The Survey of India, a government body, has fixed a set of symbols for maps of India or parts of India. A small selection of them is shown in figure 1.2 on page 12. Let's explore. Draw a route map of your locality or your village, including your home, school, and a few other important landmarks. Show the cardinal directions and use a few of the symbols shown in figure 1.2 on page 12 to mark some important features. Here are the symbols: railway line, board gauge, meter gauge, railway station. Roads, that is metered and non-metered. Boundary, categorized as international, state, and district. River, well, tank, canal, bridge. Temple, church, mosque, chhatri. Post office, post and telegraph office, police station. Settlements, graveyards. Trees, grasses. Figure 1.2, a selection of symbols commonly used in maps by Government of India. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It merely has the shape of a sphere. We say nearly because it is not a perfect sphere, but is slightly flattened at the poles. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper, it's not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try and flatten them on a table. You will see that you cannot do it without tearing them at the edge. Now consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars and constellations in the sky, etc. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metals, plastic or cardboard. Here we will study the globe representing the Earth's geography, because the globe and the Earth have the same spherical shape. A globe will better represent the geography of the Earth than a flag. Let us now explore some of its features. There is a boy and a girl. They are looking at the globe which were kept in their front. A. Understanding coordinates. Imagine a big market in a city or a town with neat rows of shops, all the same size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So you would give directions. Like, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Now consider a chessboard. To record moves by advanced players, letters are placed along the main pieces from A to H. See the image. And numbers from 1 to 8 in between the two sides. This simple system allows player to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from D to D4 as it is shown in the image. Let's explore. Using the same term, write down your move if you play back and respond with the same move. The system used in these two examples may be called a system of coordinates. Thanks to their two coordinates, the stationery shop as well as the chess square on the chessboard can be precisely determined. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. D. Latitude. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed point at the top and bottom are the two poles. Halfway between them is the equator. Note the circle, marking it. See figure 1.3. Imagine that you stand on the equator and travel towards one of the poles, or say your distance from the equator increases. Latitude measures this distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west, parallel to the equator. Such a line is called a parallel of latitude, and it draws a circle around the earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circle marked by the parallel of latitude grows smaller as we move northward or southward. Latitudes are expressed in degrees, also by convention. The equator is latitude 0 degree, while the latitude of the two poles are 90 degree north and 90 degree south respectively. This is noted 90 degree N and 90 degree S. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperate, and closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so, and also why we experience different seasons in the course of a year. There is a picture of globe. In this, we can see equator, east longitude, west longitude, south latitude, north pole at 90 degree, and different continents like North America, Africa, Europe, Asia. Oceans like Atlantic Ocean, Indian Ocean. Figure 1.3. These globes shows both parallels of latitudes and meridians of longitudes. See longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well as pass through Asia. The distance would be same. These lines are called meridians of longitude. Figure 1.3. They are all half circles running from one pole to the other. You will also learn in science that the Earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe. Focused on it and imagine that this is the sun illuminating the Earth, slowly rotating the globe eastward. We can note that for some place on the Earth, it is morning, while for others it is midday, evening or night. When it's breakfast time in one country, it's lunch time in another, and in a third country, people are fast asleep. That is why by measuring the longitude of a place, we will also be measuring the time at that place. Let us see how. To measure longitude, we needed to define a reference point called the prime meridian, figure 1.3 on page 50. It is also called Greenwich meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, would become the international standard for the prime meridian. It is marked as 0 degree longitude. Just as latitude is measured of the distance from the equator if you travel toward one of the poles, longitude is a measure of the distance from the prime meridian if you travel along the equator. Longitude, too, is measured in degrees, westward or eastward. It increases in value from 0 degree to 180 degree, with the letter W or T added. For instance, using round figures. New York's longitude is 74 degree west, while Delhi is 77 degree east, and Tokyo is 140 degree east. Don't miss out. As you can see on the globe of meridian of longitudes, 180 degree west and 180 degree east are the same longitude. So this longitude is noted 180 degree, omitting the letter W or E. Latitude and longitude together are the two coordinates of a place. With them, you are now able to locate any place on Earth. You can now understand a statement such as Delhi lies at 29 degree north latitude and 77 degree east longitude. These values are round off, not exact. Figure 1.3 on the page 15 shows the parallels of latitude and the meridians of longitude together on the globe as blue lines. All these lines together constitute a grid for the globe. They are also called grid lines. Let's explore. If the globe or atlas in your class has well-marked latitudes and longitudes, try to note down approximate value of the latitude and longitude of Mumbai, Kolkata, Singapore, Paris. Figure 1.4. This sketch shows how the prime meridian divides the Earth into the western and eastern hemispheres, while the equator divides it into northern and southern hemisphere. Don't miss out. The Greenwich meridian is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own. Figure 1.5. It was called Madhya Rekha or middle line and passed through the city of Ujjaini, today Ujjain. which was a reputed center for astronomy over many centuries. Brahmihira, a famous astronomer, lived and worked there some 1500 years ago. Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or prime meridian. The Ujjain meridian became a reference for calculations in all Indian astronomical texts. The map shows a few ancient Indian cities close to the Ujjain meridian. Some are very close to it, while others are a little away. This is because measuring longitude required accurate timekeeping, which was not as precise then as it is today. Figure 1.5. The Ujjaini prime meridian used in ancient Indian astronomy. Cities marked with a circle are mentioned in astronomical texts as being on this meridian. The modern name is given after the oblique bar. First, we will study ancient city. The Ujjain meridian is 75.8 degree east. Ancient cities Kurukshetra, first Kurukshetra, second Rohtak or Rohtak, third Malwangar Nagar, fourth Ujjain or Ujjain, fifth Mahishmati or Maheshwar, last Kumari or Kanyakumari. Modern cities first Delhi, second Kolkata, third Mumbai, fourth Bangalore and Chennai. Figure 1.6. This map, published by the Survey of India, shows the country outlined along with a few parallel of latitude and meridians of longitude. India's latitude extends approximately from 8 degree north to 37 degree north and longitude approximately from 68 degree east to 97 degree east. The two colors have been added. Understanding time zones. Let's make the globe rotate again from west to east. That is how our planet spins around its axis, making a full turn every 24 hours. A full turn is 360 degrees. So, this means 15 degree per hour. 15 into 24 will be 360. Let us now mark the meridians of longitude every 15 degrees. Moving eastward from the prime meridian, we get 0 degree, 15 degree east, 30 degree east, 45 degree east, and so on every 15 degree up to 180 degree east. This is the same as adding 1 hour of local time with each meridian. If it is 12 p.m. or noon at Greenwich, it is 1 p.m. local time at 15 degree east, 2 p.m. at 30 degree east, and so on. But going westward, it is the other way around, 11 a.m. local time at 15 degree west, 10 a.m. at 30 degree west, etc. Figure 1.7. These graph shows longitudes at the bottom and the local time at the top, with reference to the prime meridian at 0 degree. Each color is a zone of 15 degrees centered on a meridian. Let's explore. Two friends, one sitting in Porbandar, Gujarat, and the other in Tinsukia, Assam, are speaking on the phone late afternoon. The latter remarks that the sun has set in Assam and it's now dark. The former is surprised and says, "But it's still full daylight here. Explain why." And as a class activity, calculate the difference in local time between these two cities. Hint: for now, consider the difference in longitude between Porbandar and Tinsukia to be 30 degrees. Later, you can find out the precise value. The same method can be used to calculate the local time of any place on the earth. But it would not be convenient for a country to use many local times. That is why most countries adopt a standard time based on a meridian passing through them. Indian Standard Time (IST) is 5 hours 30 minutes, also noted 5.5 hours ahead of the local time at Greenwich, called Greenwich Mean Time or GMT. Let's return to the two friends sitting in Gujarat and Assam. Use this example to explain the difference between local time and standard time. All the standard times are organized in time zones, which broadly follow the zones of 15 degree in the graph. Figure 1.7. But let us consider the world map below. Figure 1.8. We can see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time and therefore tend to follow international borders. The numbers written inside some countries are the number of hours to be added to GMT or Greenwich Mean Time to get their standard time if they have a positive sign, or subtracted from GMT if they have a negative sign. Figure 1.8. A world map of the time zone showing the standard times with respect to GMT, Greenwich Mean Time, for a few countries. Note that international borders are approximate, not exact. Don't miss out. From the above explanation, it may seem as if every country has one standard time. That is not always the case. Some countries, like Russia, Canada, or the USA, are too large to have a single time zone. The USA has 6 time zones and Russia has 11, which means that traveling across Russia from east to west, you will need to readjust your watch 10 times to align with local time. Similarly, the globe in figure 1.9, centered on India, shows standard times with respect to GMT for a few countries. Finally, while the prime meridian was fixed at Greenwich, the opposite line at approximately 180-degree longitude is called the International Date Line. As you can see on the map, the +12 and the -12 time zones touch each other at this line. If you cross this strip by ship or plane, you need to change the date in your watch. If you cross it Figure 1.9, a few time zones with respect to GMT in Africa and Eurasia. Traveling eastwards, you subtract a day, say from Monday to Sunday. If you cross it traveling westward, you add a day from Sunday to Monday. We said that the international date line is approximately at 180-degree longitude, as it deviates in places to avoid dividing some countries into two different days. Before we move on, maps are a very useful tool to represent an area of the earth, whether small or large. The main components of maps are distance, direction, and symbols. Every place on the earth has a location which can be precisely defined with the help of a grid of latitudes and longitudes, imaginary lines running from east to west, parallel to the equator, and north to south from pole to pole respectively. Longitude also marks the time and defines the time zones. The international date line is located approximately at 180-degree longitude, opposite the prime meridian. Crossing the international date line changes the date by 1 day. Estuary. The place where a river meets the sea is called estuary. So with this, we have completed chapter 1 of our social science. Thank you.